Hello, everybody. Welcome to your course on the default mode network and its role in psychedelics. My name is Hadley Pierce. I'm a neuroscientist turned science communicator who spent over 10 years in academic research before shifting focus to helping communicate science in ways that are understandable and relatable to the public. I'm very excited to be here, and I'm grateful to Dr. Brenna Bray for the opportunity to speak with you. I also wanted to just mention that I have a stutter. It tends to be heightened when I'm giving presentations. So I ask that you just bear with me and be patient while I stumble through sometimes during our talk. So thank you for that. So let's dive in. The default mode network is a network of brain regions that's active when the brain is at rest or not focused on a specific task. So for example, when we're daydreaming, feeling like we're spacing out, or when our minds freely wander. It was accidentally discovered in 2001 by Dr. Marcus Rochelle at the University of Washington. While his research was focused on brain metabolism during different cognitive functions, he noticed a consistent pattern of certain brain regions consistently decreasing activity during tasks. They termed this the default mode because it appeared to be when the brain was defaulting to these areas and not engaged in specific functions. This was a shift from studying what the brain does during tasks, so being active, to what it does during rest, challenging the old idea that the brain is inactive when not engaged. The discovery of the default mode network changed core assumptions about consciousness and brain function, as it worked in opposition to attention-related networks. And when we're focused, the default mode network activity decreases, and when we're resting or thinking inwardly, activity increases. There are three main areas of the brain that are involved in the default mode network. The first is the medial prefrontal cortex, right at the front of your frontal lobe. This area is involved in self-referential thinking, moral reasoning, and social judgment. It integrates emotions with cognition as a part of the limbic system. It orchestrates activity, like network activity, similarly as a conductor orchestrates an orchestra, or conducts and leads an orchestra. The posterior cingulate cortex integrates internal thoughts with our external environment. It's the central hub with the highest connectivity, so the most metabolic activity, and it's hyperactive in depression and is the target for psychedelic therapies. The inferior parietal lobule, or in the angular gyrus, play a role in perspective taking and imagining scenarios. It supports our ability to visualize future events or mentally simulate outcomes, and it also is implicated in narrative comprehension and creativity. Other areas that are involved in the default mode network are the retrosplenial cortex and precuncus, which it has a role in spatial memory, time, and context thinking, or contextual linking, sorry. It's part of the hippocampus is involved with episodic memory, imagination, and personal history. And the temporoparietal junction is involved with social cognition, empathy, and moral reasoning. So what are the roles of the default mode network? There are kind of 5 primary cognitive functions that are linked to the default mode network. Remembering a personal life event, so assessing personal memories and experiences, reconstructing past events with an emotional context. It's important for building identity and self-continuity, so who we are in ourselves and who we believe ourselves to be. It's involved with future planning and visualization, so it helps create mental visions of future scenarios. It's a key part of planning and decision making. It allows for mental time travel using past experiences to imagine future goals. And then is supported by connections with memory regions like the hippocampus and the hubs of the network. It also plays a role in self-related thoughts and introspection. So it's active when we think about ourselves, our identity, feelings, and goals. It creates a coherent sense of self. It supports repetitive internal thoughts like daydreaming or rumination, which are essential for building this self-continuity and identity and feeling strong in who we are as a human. It also is important for social cognition. It helps us recognize and understand others' thoughts, intentions, and emotions, and promotes feelings of empathy. It helps us gauge what others might be thinking or feeling without clear cues. And finally, it plays a big role in moral reasoning, helping us with ethical thinking and forming value-based decisions, including weighing intentions, consequences, and fairness in hypothetical situations. It supports judgments that go beyond simple rules. So like rules that we think are fairly basic and straightforward. Our brains naturally have the ability to have beneficial effects through neurotransmitters that already exist, but psychedelics can help tap into these natural abilities. They do this through serotonergic receptors. So classic psychedelics bind to 5-HT2A receptors, which are a form of serotonergic receptor, which triggers serotonin-like effects. So these are feelings of happiness and well-being, calm, helps with emotional regulation and feeling kind of emotionally balanced. This is why certain psychedelics, particularly psilocybin, DMT, and LSD, have shown promise as therapeutic agents in improving symptoms in patients with major depressive disorder. They enhance neuroplasticity, creating new connections between brain cells. And when it comes to DMT, the PCC is particularly affected by changes in the serotonin system, so decreasing activation in the default mode network. Serotonergic psychedelics like psilocybin, LSD, and ayahuasca decrease functional connectivity in the default mode network while also increasing total activity in the brain. Each of these has a similar action with slightly different effects. So ayahuasca may have more targeted effects that promote emotional release, changes in self-processing, and a separation of ego. LSD creates a stronger and more widespread change, increasing overall brain connectivity, which allows regions of the brain that don't usually communicate to talk, leading to new insights and an experience sometimes of synesthesia, which is when you experience kind of cross-sensory experiences. So for example, when you see colors when listening to music. Psilocybin reduces activity and connectivity in the default mode network, which may explain the experience of altered consciousness and a dissolved ego. This happens by reducing the connection between the medial prefrontal cortex and the PCC, which are two main areas involved in self-reflection, reducing rigid thought patterns, and self-regulated thoughts. We're still learning about how this action happens, with research suggesting that this comes from the interaction with this serotonergic receptors, increasing brain activity. And research has actually shown that by blocking these receptors, you reduce the sensation and the effects of psilocybin, which is therefore impacting the default mode network function. This suggests new ways to understand and treat mental illness, especially those involving rigid, overactive self-focus. There are several ideas or models for the idea of focusing on functional connectivity. These are the changes in connection of the default mode network and the brain in general, which seem to be one of the main ways that psychedelics affect the brain. There are kind of 4 primary models that suggest how this might work. They are the relaxed benefit under the psychedelics model, or the rebus model, the cortical striatal thalamocortical model, strong prior model, and the corticoclaustral cortical model. They're a bit of a mouthful. So the rebus model describes how psychedelics loosen the rigid patterns that our brains try to predict our own experiences. So our brains constantly are trying to predict what we see, hear, or feel. And this model suggests that psychedelics break down these rigid patterns. It combines 2 ideas: the entropic brain hypothesis, which states that psychedelics increase brain flexibility and reduce order, and the free energy principle, which is where the brain works like a prediction machine, constantly guessing what will happen next and updating its beliefs based on what it's. By activating our serotonin receptors, psychedelics reduce the brain's confidence in these pre-existing beliefs. And this makes the brain more sensitive, less controlled by rigid expectations, and more open to new experiences. The CSTC model suggests that activity of the psychedelics comes from the 5-HT2A receptors, reducing unnecessary sensory inflammation. So we can be overstimulated. And so this works by reducing what's called sensory gating in the thalamus, which is the area you see here, and increases the amount of sensory information getting into the cortex, which can explain why so many of our psychedelic experiences are so sensory. The strong prior model proposes that the brain relies too much on our internal predictions. This is a more neuropsychological approach that states that the psychedelic experience may come from reduced incoming sensory signals, while the brain becomes more influenced by its own beliefs and expectations. And the CCC model states that psychedelics disrupt the connection between the prefrontal cortex and the claustrum, which has a high density of 5-HT2A receptors. So this impairs the connection, which affects coordinated actions and disrupts higher cortical networks through the circuit. So again, it's loosening up and challenging these rigid processes that are already involved in the brain to help open up new thoughts and new experiences. And this is particularly important when it comes to the default mode network, when increasing entropy or brain disorder, and which disrupts the default mode network function and reduces preconceived ideas and rigid thinking. So when we look at the default mode network and how it functions with the influence of psychedelics, we also see that there are similar things that we can do to promote or kind of mimic those feelings. So while psychedelics help promote altered states of consciousness and can impact emotions and cognition and perception, practices like meditation and movement can also affect the default mode. So for example, meditation has shown to have various effects on the default mode network. One effect is that meditation can change the functional connectivity between different networks and decrease activity, which is very similar to how psychedelics act. On the other hand, other studies have found that an increase in functional connectivity between the default mode network and brain regions involved in focus and identifying what's important have been activated. These include the potential executive network and the salience network. These connections may lead to more awareness and reduce mind wandering and help increase focus, which are things that we think about in meditation. So it might depend, the difference in these results might depend on the type of meditation being done, but more research needs to be done to come to that conclusion. This trend seems to be consistent across different types of meditation, but is likely connected to focus required during. So the trend being an effect of the default mode network, even though it might vary. Movement and exercise, particularly mind-body type exercises like yoga and Tai Chi and Qigong, have shown to improve functional connectivity when we're resting. So this means stronger networks between the default mode network, the dorsal attention network, which is linked to focusing on goals and filtering distractions, and the ventral attention network, which helps detect important external stimuli. So key takeaways are the default mode network is our mental rest mode. It's our hub for self-reflection, memory, and future planning. It's central to how we understand ourselves. Psychedelics can offer a powerful reset, reducing default mode network activity. They can help us relax our deeply held beliefs and habitual thought patterns. This opens doors to new perspectives, insights, and healing. The Rebus model in particular helps show us how this works, along with the other models. The state of increased openness and activity allows the brain to be more receptive to new experiences. It may be the key to long-lasting psychological change. Meditation and movement also support the default mode network changes. And the default mode network reminds us that the brain is never totally resting, but may be one of the most promising paths towards emotional healing and self-understanding. Thank you so much for your attention. I hope you learned a lot and enjoyed learning about the effects of this really interesting area of the brain. If you'd like specifics on the references, I will make sure that Dr. Bray has the full list and access. And I wish you all the best.